Hello. For my science fair experiment, I studied the effect of aperture on depth of field. Depth of field is what part of a photograph is perceived to be in focus. Aperture is the ratio of the length of a camera lens to the width of the hole which the light goes through. In this project, the length of a camera lens was a constant, so the aperture was determined only by the width of the hole that the light goes through. I wanted to study this because I take pictures of my dog a lot, and I want to know how to make it so that the background is in focus, or so that the background is blurred with my dog standing out. I hypothesized that a wider aperture would cause less to be in focus, because to focus on one distance of light, it would need to cross it at a sharper angle, so the light that is not in focus would go further from being together or be less in focus. My plan was to take many pictures at apertures that would double between each picture, and to ask people which subjects are in focus. I set up the pictures with 9 water bottles. 1, 2, 3, 4, 5, 6, 7, 8, 9. Spaced such that each water bottle was about the fourth root of 2 times the distance of the last. I showed the pictures to 15 participants, and on average, the picture with the widest aperture had 2.53 bottles in focus, which is this picture. The second picture averaged 3.6 bottles. The third averaged 5.33 bottles, and the fourth averaged 7 bottles. Here's the fourth picture. Overall, with 3 doublings in aperture, there is a total difference of 4.47 bottles in focus, and an average difference of 1.49 bottles difference of how many were in focus per stop. This shows a distinct positive trend between aperture and depth of field, where a doubling in aperture corresponds to a larger depth of field multiplicatively, so aperture linearly affects depth of field because the bottles were spaced with multiplying distances. So that proves my hypothesis correct.